Today I'm going to discuss the definition of the speed of light. Now, speed involves a definition of time and a definition of distance. For absolute time, we have the atomic clock. That's fairly straightforward. Now, historically, the absolute speed of light was determined to be roughly 3 times 10 to the 8th meters per second. And this was determined by using a meter stick, astronomy time, and the ether theory, which is necessary to have the concept of an absolute speed of light. Now, now that has changed. Now, by definition, the speed of light, c, is 3 times 10 to the 8th meters per second. Actually, that's a 10-digit number, which I didn't want to write, obviously didn't want to write on them. So when you see 3 times 10 to the 8 meters per second, think of that as a 10-digit number. You can look it up easily enough. With that, absolute distance now is defined by 1 meter is 3 times 10 to the 8th meters per second times the time in seconds, where t, from the absolute time, is 1/3 times 10 to the minus 8 seconds. All right? Now, in general, the velocity of a photon with respect to the source is its absolute velocity, Vp, with respect to the absolute reference frame or ether reference frame, plus the velocity of the ether absolute reference frame with respect to the source, where the velocity of p with respect to a is the absolute speed of the velocity, which is equal to c. And I've just drawn a schematic here. As some examples, we have the Michelson-Morley interferometer, where for the vertical path, we have a mirror, we have the photon reflected vertically with an absolute velocity Vp with respect to A, and then we have the source velocity of the table, Vs with respect to A, and then this equation applies. For the horizontal path in the Michelson-Morley interferometer, we have the horizontal speed of the mirror, which is the horizontal speed of the table. Then we have the absolute velocity of the photon with respect to the ether in the horizontal direction. From that, you get the result that there is no interference to be expected from the Michelson-Morley experiment, and there is none. Now, for the Sagnac ring interferometer, which I've just made a sketch of here, and it's easier to look at it in terms of a train, if you will, where you unwind the two circular links to make one long train. And this is moving with the velocity of the source, with the absolute velocity of the source is v times I, and the absolute velocity of the photon with respect to the ether is c times I, from which you get that, using this formula again, the velocity of the photon with respect to the source is equal to c minus v times I, in which case the time for the photon to get to the end or go around one cycle in this direction is L divided by the relative speed, c minus v. In the other direction, the time is L over c plus v, from which you get a delta t given by this, which is the standard expression for the difference between the time of arrival of the two paths for Sagnac interferometer. For reference on these things, click on the video link below. Thank you very much.